Lastly, we have another stress to consider. Let's consider a situation where we have two bolted members in tension as shown below. We have the bottom of a hitch, which has an applied force F1, and the top of a hitch, which has an applied force F2, and a bolt runs in between said members. Now, the bolt is going to transfer force between said two members. And by Newton's third law, our bolt is going to exert a force F2 onto our top member, as shown by the red line, and F1 on the bottom member, as shown by the red line. Now this force, F1 or F2, is going to be acting over the surface of the bolt hole within each of these members. And this force is going to cause a stress in each of these members. Additionally, these forces will cause a shear force and subsequently a shear stress in the bolt. For us to solve for the stress of this member, we will project our curved surface of the bolt hole onto a plane, as denoted by our red shaded surface in the image below. Thus, we can say F2 is going to be exerted on the surface. Now, this surface has a thickness T and a width D. Therefore, the bearing stress that one of these hitch members experiences is defined as sigma sub B, where B refers to bearing. And this is equal to a reactionary force per the area for which this force is applied, which is equal to R per TD, where T is the thickness of the member and D is the diameter of the bolt hole. And this is equal to R per our bearing area, denoted as A sub B. And once again, stress has units of pascals. To see this in application, let's consider a wood block that is used to transmit force. The right side of our block has two steel plates, one on top and one on bottom. A steel pin connects these steel plates through the wood. Now the assembly is loaded as shown, where we have a 20 kN force applied to the left and two 10 kN forces applied to the right. We want to determine the bearing stress in the wood and a steel plate. First, let us consider the bearing stress in the wood. The bearing stress in the wood is going to be a reactionary force per our bearing area. Our reactionary force is going to be 20 kilonewtons, and our bearing area is going to be the height of the through hole for the pin, which is 5 centimeters, times the diameter of the pinhole, which is 1 centimeter. And we find our bearing stress in the wood to be 40 megapascal. Now the bearing stress in the steel plate is found as follows. We would determine our reactionary force and divide it by our bearing area. The reactionary force for a single steel plate is 10 kilonewtons, and our bearing area is going to be a thickness of half a centimeter times the diameter of our bolt hole, 1 centimeter. And we find our bearing stress of the steel to be 200 megapascals.